This is the screencast for section 3.1, example 4. We are going to graph f prime from f. So in other words, we're going to be given the original function and now we're going to graph the derivative. Now I switched the directions from example 4. Your book wants you to start with the derivative and then graph f, but we're doing that in the now try problem, and I think it's important to understand this both ways. So we're going to start by sketching the graph of a function f prime. So here's the graph of f. F prime represents the slopes of f at specific x values. So the slope clearly changes. Here it's negative and then here's it's positive. So the slope clearly changes at 1. Well, I'm going to look at the slope before 1, and that slope goes down 1, right 1, down 1, right 1. So that is a slope of negative 1. Now here to the right of the x value positive 1, the slope here is 2. I mean, you could find 2 points and do the slope formula if you want, but I can just see that it goes up 2, right 1, up 2, right 1, etc. So that means that the y value is going to be 1 for every single x value before x equals 1. So at x equals 0, the slope is negative 1. At x equals, let's see, negative 2. Oh, slope is still negative 1. How about at x equals negative 3? Slope is still negative 1. So my slope is always going to be negative 1 up until we get here. At x equals 1, that slope is it's undefined because there's no derivative there. Where exactly would you put that tangent line? Would you put it there? Would you put it over here? Are we going to use the slope of 2? Are we going to use the slope of negative 1? I don't know. So we're not going to put a slope at all there. We're going to leave an open circle. Now, the x values to the right of 1. Let's see, at 2, the slope is 2. At x equals 3, the slope, still 2, etc. So we're going to do the same thing. At x equals 1, we're going to draw the slope to be 2, but an open circle. So there's no clear slope at x equals 1. There's a clear slope after and a clear slope before, but that's it. So f prime, the value of the slopes, would look like this on a graph. The now try problem number 27 says graphing f from f prime. So now we're going to be given the graph of the derivative, and then we're going to graph f. So first we need to graph this piecewise function of our derivative. So our derivative has the value of 1, so y equals 1, for every x value less than negative 1. Not equal to, so there's an open circle. So all the way out here, we have the y value 1, anywhere x is less than negative 1. Anywhere x is greater than negative 1, the y value is negative 2, so the slope is negative 2. All the way out that way. So now let's draw the graph of f. Let's look at to the left of negative 1 first. To the left of negative 1, the slope is always positive 1. Well, what has a constant slope? Well, lines do. Lines have a constant slope. Well, I don't know where to put this line with slope 1. Do I put it there? Do I put it here? I mean, it doesn't say anything about the y-intercept. So here I have to go back to the original instructions and say sketch the graph of a continuous function f with f of 0 equals negative 1. F of 0 equals negative 1. So that's down here. So actually I'm going to change my tune a little bit. I'm going to start with this piece. Any x value greater than negative 1, so to the right of this dashed vertical line, has a slope of negative 2. So it's going to go down to right 1. So down to right 1, up to left 1. So that is what this piece is going to look like. Now, why did she draw a solid dot there? Well, it says that f is going to be continuous, so I know that I have to have a solid dot there. I can't have a removable discontinuity. I also know that the piece then to the left of -1 is going to pick up where the other one left off. So that slope is going to be +1, down 1, right, left 1, down 1, left 1, etc. So that slope is a little bit shallower than the other piece. So now I've drawn a continuous graph of f of 0 equals -1 right there. The slope where x is less than -1 is +1, going up to the right, +1. And the slope where x values are greater than -1 is -2, down 2, right 1, down 2, right 1.